Hello everyone, I hope you're all doing well. In this video, we're going to be taking a look at some IB chemistry questions regarding oxidation and reduction and that whole redox chapter in general. Now, these questions were sent to me by a subscriber and they're not of any, actually, I don't know which paper they're from, but I just have the questions up over here. If you do recognize them, um, feel free to let me know, but I don't actually know which papers these are from. But I'm going to take a look at two questions today. So the subscriber had sent me quite a few questions, and I tried to do most of them in one video, and it turned out to be like 40 minutes long. So I'm kind of doing a retake, and I'm just gonna take a look at two of the questions, and then I'm gonna take a look at the other two maybe tomorrow or some other day. Okay, so here we have question number one. It says, consider the following standard electrode potentials. You have three electrode potentials, and the question is, which species will reduce H plus to H2 gas under standard conditions? Now, before I proceed with explaining the answer to the question, I want you to give it a go. Because your exams are pretty close, and by now you should at least have an idea of how to solve this question. If you get the right answer or not, it's all right, but you should have sort of an idea, or you should have the right sort of direction as to where to go with this question. So I want you to give it a shot. I'm just going to wait for a couple of seconds. All right, I hope you've paused the video and attempted to solve this question yourself, but now I'm going to get on with explaining why the answer is what it is. So, okay, when you are given such a question, when you have been given the electric potentials, I want you to remember two things. If the E naught or the electric potential is high, that means that the species or the ion is likely to gain an electron and get reduced. However, if the E naught is low, that means that the reaction is likely to go in the reverse direction where the atom becomes ionized and it gives away an electron, because that's what oxidation is. Oxidation is the loss of electrons, right? So I'm going to take an example of these two equations that are written over here. So we have Sn, which has an E naught of negative 0.14, right? What does this mean? What can you take away from this information? What you can take away from this information is that Sn is more likely to form Sn2 plus and give away 2 electrons rather than Sn2 plus gaining 2 electrons and forming Sn. This is less likely to happen. This is more likely to happen. And this is because of the electrode potential. We can determine this from the electrode potential. Again, if the electrode potential is low, the reverse reaction or the oxidation reaction is likely to happen. However, if the E naught value is high, that means that the reduction reaction is likely to happen. And just a quick recap, reduction is the gain of electrons, oxidation is the loss of electrons. So in this case, in this equation of Sn over here, oxidation would be losing electrons. That would be the reverse reaction going backwards, forming Sn2 plus and 2e plus. However, the reduction reaction would be Sn2 plus gaining 2 electrons and forming Sn. And out of these two possible directions, we have determined from the E naught value, which is low, which is negative, we have determined that Sn is more likely to form Sn2 plus and 2 electrons. Sorry, it's very weird. I don't know why I have E plus there. That doesn't make any sense. It's E minus. But we have determined that Sn is more likely to form 2 electrons, or to give away 2 electrons and form Sn2 plus. Now let's kind of look at the other side of things. Let's take a look at Fe3 plus. In this case, we see that Fe3 plus this reaction over here has a very high electrode potential. And what does this tell us? This tells us that Fe3 plus it likes to gain an electron to form Fe2 plus. So the reduction reaction is more likely to happen. However, Fe2 plus does not like to give away an electron and form Fe3 plus. This is a no-go. This is not a suitable reaction. Fe3 plus is happy to gain an electron and form Fe2 plus. However, Fe2 plus is not happy to be oxidized. And this is kind of the opposite of what we see with Sn, where Sn is happy to give away electrons. However, it is not happy, Sn2 plus is not happy to take electrons. But in this case, Fe3 plus is happy to take electrons, but Fe2 plus is not happy to lose electrons. So really, what I'm trying to put across over here is that this reaction, which is oxidation, is likely to happen in this scenario over here. And this reaction, the forward reaction, which is, as you guessed it, reduction, is likely to happen in this scenario. I hope that makes sense. Just remember, if the E naught is high, it will be reduced. If the E naught is low, it will be oxidized. So again, this brings us back to our question. How does this help us in our question? It asks us which species will reduce H plus to H2. So we know that we need H plus, or 2H plus rather, to gain some electrons to form H2 gas, right? We need this to happen. If we want 2H plus to gain electrons, that means we want it to be reduced. And if something is getting reduced, something else has to be oxidized, right? So something else has to be oxidized. Now, out of these two, out of SN and out of Fe3 plus, which one is going to be oxidized? Which species is going to oxidize H plus? Well, we know that oxidation is a loss of electrons, and we have also determined that Fe2 plus does not like to lose electrons. Fe2 plus does not like that. It would rather Fe3 plus gain an electron and form Fe2 plus, and Fe2 plus does not like to give away electrons. However, what likes to give away electrons? What have we determined? We've also determined that Sn is very happy to give away electrons. Sn will give away electrons, will give away 2 electrons to form Sn2 plus. And wow, would you look at that? It's a perfect setting. So we know that what's going to be oxidized is actually Sn. So Sn is going to give away 2 electrons and form Sn2 plus. And then these 2 electrons can be used by 2H plus to form its H2 gas. So which species, oops, looks like I've overwritten the question. So which species will reduce H plus to H2 gas under standard conditions? Well, the answer is C, Sn. Now, I've seen many students make this mistake. They're in a rush in the exam. They look at the electrode potentials. They see, oh, Sn2 plus 2E minus, giving Sn has a very low electrode potential. It has a lower electrode potential than H plus, right? Well, what we can do is simply put Sn2 plus as the answer. Well, that's not correct. Sn2 plus does not get oxidized. Rather, it is Sn which gets oxidized to Sn2 plus, if that makes sense. So the correct answer is Sn. Now, a faster way to do this question, like what I've done over here, is I've really gone into detail with the process that you should be thinking of when solving this question. But a faster way to do this is simply to look at the E naught values. If the E naught value is higher than for H plus, if it's higher, for in this case, we have Fe3 plus E minus giving Fe2 plus has an E naught value which is higher than the one for hydrogen. That means that this particular reaction over here will not reduce H plus. And since this has a lower E naught value, this will be the one which will reduce H plus. So hopefully that makes sense. That's a faster way to do it. And again, if I just sort of unblur the mark scheme answer, it's C, which is the answer we got, and hopefully that makes sense. All right, let's take a look at the next part. I'm just going to sort of erase this over here. Okay. We have, what are the major products of electrolyzing concentrated aqueous potassium iodide? Now, again, I want you to give this question a go by yourself, and then I will proceed to solve it. Okay, I trust that you have given it a go, and well, let's take a look at this. So we have electrolysis reaction. We have an electrolysis reaction, and it's of concentrated aqueous potassium iodide. Now, the key words are concentrated and aqueous. So aqueous means that H2O is present. So we have Ki and then we have H2O. Now, when you electrolyze, right, you're using electricity to split apart the molecule. So you end up with K plus and I minus, and we sort of just keep H2O like it is. We don't split H2O apart. And they're asking us what products we're going to get at the negative electrode, which is the cathode, and the positive electrode, which is the anode. Now, out of these two sort of groups, which one do you think is going to go to the cathode to get reduced? Now, you may have guessed this group, and you would be absolutely correct. This group is going to go to the cathode, and this group is going to go to the anode. So why does this happen? Well, because this goes to the cathode, because remember, at the cathode, we have reduction, and at the anode, we have oxidation. So I minus is not going to go to get reduced because it is already reduced. It already has an extra electron. It can't take another, right? And K plus is not going to get oxidized because it is already oxidized. It has already lost an electron. So it's going to want to get reduced. So both K plus and H2O are going to go to the cathode. So they walk over to the cathode. Now, at the cathode, we have a reaction like this, right? At the cathode, one of two things can happen. You can either have this happening, one, or you can have number two happening. You can't have both, right? You can either have K plus gaining an electron to form potassium, or you can have H2O gaining an electron to form some hydrogen gas. I forgot to put the state symbol over here, right? You have either one of two happening. Now, which one is more likely to happen? Well, the first thing that you should always think of is, do alkali metals, right? Do alkali metals, do they want to, or do the ions of alkali metal want to gain electrons to form their non-ionized state? Do they want to do that? Or do they want to rather lose an electron to form their ionized state? Which one do they want to do? Well, if you guessed that they want to lose electrons, you're absolutely right. K will rather lose electrons and form K plus rather than K plus gaining an electron and forming K. And this is sort of it's what we see in chemistry very often. We see K forming a positive ion by losing an electron, right? We very rarely see K plus gaining an electron to form K, because K plus is much more stable than K. So we see that this reaction, this forward reaction of K plus gaining an electron to form K, or to form potassium, is not going to happen. It's a very unlikely reaction. It's not going to happen. So this reaction is not going to happen. Rather, we're going to see, number two, we're going to see H2O gaining an electron to form hydrogen gas and OH minus. So what is going to be our product, our major product at the negative electrode? Well, it's not going to be potassium. We've just discussed that. It's not going to happen. This is an unlikely reaction, right? It's an unfavorable reaction, rather. We're going to form some hydrogen. So now our answer is either B or C. Now, what is it going to be? Are we going to form iodine or oxygen at the positive electrode? Now, obviously, you have iodine if I minus chooses to get oxidized, right? And you're going to have oxygen if H2O chooses to get oxidized. So which one is it going to be? Which one of these two is going to get oxidized? Now we come to the second part that I told you to remember, which is concentrated. They've mentioned concentrated aqueous potassium iodide. And when the solution is concentrated, this always means that the halogen is going to be formed at the positive electrode rather than oxygen. So we can delete C and we can put our answer as B, which is also the correct answer. So if they mention concentrated, you already know that the halogen will be formed, in this case, we have iodine. If it was chlorine, it would be the exact same. You have chlorine. If it was fluorine, it would be fluorine, right? If it says concentrated, you have the halogen being formed. I hope that's made sense, right? Okay, now I want to come back to one small thing that I didn't really cover. When they ask what are the major products of electrolysis, I say the major products, right? Whenever I speak of the of reactions happening at the electrodes, I use terms like unlikely or unfavorable. And unlikely or unfavorable does not mean that it will never happen, right? The reaction of K plus gaining an electron to form potassium can happen, but it will happen very little. This reaction is not going to happen very often. However, this reaction will happen often. So your major product, the major substance that you're going to get at the negative electrode will be H2 gas. And similarly, at the positive electrode, your major product, the product that you're going to get the most is iodine. However, this does not mean that you will get no oxygen. You will also get some oxygen, but that is not your major product. Your major product, your chunk, is your iodine. All right, I hope that's made sense. Okay, so that is it for this video. I hope that this video has helped you. If you do have any questions, please let me know. Message me on Instagram or send me an email. I'll be more than happy to help you. Thank you so much for watching this video. I will see you in another video with another question. Probably tomorrow I'll take a look at 2 more questions regarding redox, and that is it. Goodbye.